All right, ladies and gentlemen. Now we're going to start with the Fireside Chat, which is about manufacturing in space. We will discover the future of manufacturing in microgravity. We'll learn how in-space production can create superior materials, reduce cost, and revolutionize space exploration. Please help me welcome Dr. Sathyan, professor at Indian Institute of Technology, Madras, and Mr. Raghu Das, co-founder, CEO, Almagest Corporation. Can we have a huge round of applause? Thank you so much.
Good afternoon. My name is Raghu Das. I am partner of E2MC Venture in addition to co-founder of Almagest Corporation. So I had privilege of meeting Dr. Sathyan in last week or 10 days ago in Washington, D.C. in a in-space manufacturing conference. And I learned a lot from discussion that we had in Washington. I thought that we'll extend that to here in Delhi and learn more about it. And he's heading the research center in IIT Madras about extraterrestrial manufacturing. So we'll keep the discussion. I'll have some question that we'll do Q&A, and then we'll also open to audience and if you have any question and you want to know. This is one of the newest space sector that is opening up, has immense potential.
Yeah, thanks, Raghu, and thanks for having me here as part of the Fireside Chat. So as Raghu mentioned, I'm basically a professor in the Department of Mechanical Engineering at IIT Madras. I've been trained in manufacturing science and engineering. That's what I've been trained in. The last 3 years or so, we started this research center on what I call as extraterrestrial manufacturing, but you will hear the terms in-space manufacturing, in-space service assembly and manufacturing, ISAM. There are many terms that people are using, and NASA also calls it INSPA, in-space production applications, for example. So many terms are there. So we started doing some very preliminary work, fundamental work on how microgravity influences manufacturing processes. And as I'm reading more and more into this, there's a lot of commercial potential as well. So this is, as Raghu said, this is a really an upcoming area that we will discuss more about. Yeah, thanks.
I think let's start with giving an introduction, Dr. Sathyan, to see what is actually in-space manufacturing, why what is the focus area, what the technology's potential to the humanity as such. Okay.
Of course, all of us are familiar with manufacturing in the earth, in the context of the earth. We know that there are factories there. Factories receive raw material. They convert raw materials into finished goods, and we use various products in our life in various ways as well. Now imagine the same manufacturing now happening beyond the earth. Yeah? When I say beyond the earth, it can be in the immediate orbits of the earth. It can be on the surfaces of the moon, Mars, on other planetary bodies as well. So that's the general term that is used for in-space manufacturing. Manufacturing beyond the confines of typically low Earth orbit or beyond the common line and beyond. That's sort of how we've been defining in-space manufacturing. Of course, the question comes, why would you want to manufacture in space? One immediate thing that you can think of is if, let's say, we want to have a habitat on the surface of Moon or Mars, it's not possible to take everything from the Earth all the time. You know, although the launch costs are coming down, per kilogram costs are significantly lower compared to how things were earlier. It's still not possible to take things, raw material and finished goods all the way from the Earth to various, even if it's LEO orbit or the surface of Moon or Mars. So if we can actually make things manufactured using the raw material is available on the surface of the Moon or Mars, which is right now the regolith, what we call as regolith is basically the soil that is there, for example. That is one popular topic now for development. It's, I mean, not only just research, but technological development is how can I take the surface soil that is there, regolith, and make things out of it, for instance. Yeah. So if you have to settle down on the Moon or Mars, you have to have an ability to manufacture things there using the raw material that is available, with some help from the Earth, of course. That is one thing. The other thing that has more commercial potential is how I can have factories that are revolving around in the orbit around the Earth, where I'm exploiting mainly microgravity, the lack of gravity that is there. I can make things that are suitable for microgravity that I can bring back to the Earth and then commercialize it, for example. Okay, so that has a lot of commercial potential, which we call as in-space production applications. So you can classify them as two things: manufacturing in space for space use, and the other one is manufacturing in space for bringing it back on the Earth and use it. So that's how I would call as manufacturing in space manufacturing.
I think that's great. I think, the in situ manufacturing would be basically something maybe we have to do and start living in space, right? But I think more important today is basically what can we do in space and bring back to Earth. I think that's more of a, maybe currently or maybe next 5 years business plan, I would say.
Correct. Yeah. So I mean, it will be like what NASA calls it as low Earth orbit economy. So the plan is to, or at least NASA's plan is to have a commercially exploit microgravity. So for example, here you will have seen a lot of things about satellites, right? Today we make satellites, we send the satellites equipped with various sensors. The satellites go into the orbit, they collect data, the data comes back, and then we use the data, right? Now imagine the satellite as a new platform, which is basically like a factory. Yeah. So as a manufacturing engineer, I see now the satellite as a new micro factory, or whatever you want to call it, right? Now we assemble the raw material in that satellite. The satellite gets launched, and under microgravity conditions, it converts that into suitable products. Now I have to retrieve the satellite back, which we normally don't do in telecommunications. So I need to bring the satellite back along with the finished products, and I can use the finished products on the Earth. Okay, so that's what low Earth LEO economy is all about. That is one model. Other model, of course, is my factory is a permanent platform, like an ISS revolving around the orbit. I send my raw material, ship it to that. Okay, it converts into products, and then another retrieval system brings it back to the Earth, and we use it. So that's sort of the model that's there.
Okay, thank you. I think one of the thing is doing in space manufacturing, the technologies that we need. Are the technology ready now? Are we ready for those technologies? Because specifically, right now we have technology to basically make it effectively or inexpensively go to a LEO orbit. But coming back has been very difficult.
Correct.
So how could you basically practically make a in-space manufacturing commercially viable? Because today, coming back is only from ISS today. I know some of the companies are working on it.
Yeah.
So do you see the technology, Earth return, is a significant importance to it, and then that's something we basically need to work on?
Yes. So for in-space manufacturing to be a viable method of making products, the products have to come back to the Earth, right? So as you rightly said, Raghu, the retrieval systems are very important. Yeah. I know in India we are very strong in launching stuff. I think and I know that there are some, for example, with the ISRO's Gaganyaan mission, human safety would be the environment for that would be resolved. Of course, bringing back also will be a technology that will be developed as well, and I'm hoping that will get spun off commercially as well. Of course, worldwide there are different technologies that are already being deployed to retrieve and bring back systems, for instance. But that is definitely crucial. Compared to launch, of course, it's a little bit behind in terms of technological development, but I think we will get there. That is definitely needed for in-space manufacturing to work. Yeah. So launch costs. So the economics of that has to come down. It's already coming down, and then having a platform there which we can access to put equipment that can work in mostly in an automated manner, which will convert the raw material into products, and the processes needed for that will work under microgravity conditions. Retrieving the systems back, and of course finding commercial value for those products on the Earth. So those are all important for the in-space manufacturing to be viable.
Actually, that is true. Actually, we as an investor, we have in portfolio company like out of 16 companies, we have 4 of them in space manufacturing, and 2 of them Earth return, Atmos in Germany and Space Force in the UK. So I think those 2 companies are on Earth return. So,
okay.
So, so what is, see, you want to do something in space manufacturing, definitely it's expensive than doing terrestrially. There must be some selection process. What material actually is better manufactured in space and what manufacturer in here? Like we talked about like organoid, we're talking about protein synthesis, electronics and the fiber optics. And so what is practically and commercial viable material to manufacture?
So if you look at the various materials or products that people are thinking about, of course, these are, the main thing we're exploiting here is microgravity, right? So you think about what processes that gravity actually influences. So here on Earth, we take gravity for, we don't even consider it because it's always there. We can't like switch it off, right? It's always there. But if you think about what are the things that gravity influences, gravity influences mainly things in the, where the material is in a loose state. It can be gas, it can be liquid. Gravity typically does not influence that something that is in a solid state already, right? Okay. But of course, a lot of the processes that we use, we convert from liquid or gas state into solid state, right? So if I take some of those processes, an example would be crystal growth, for example, right? I want to grow crystals. Crystals can be grown from a liquid state, from a vapor state, for example. And the moment you're in liquid or vapor state, gravity has a strong influence on these processes. Convection, for example, sedimentation, buoyancy. So gravity is always acting on these molecules of materials and then influencing how they settle down to become solids, for example, right? Now, if you take those processes up in space and you switch off gravity because of the fact that you're in free fall, continuous free fall, for instance, so then you're now influencing how those molecules become crystals, for example. Yeah? And it turns out that the lack of gravity actually can help you get better crystals, for semiconductor crystals if you take, for example, silicon carbide, gallium nitride, diamond, for instance, right? Okay, so if you're going from a vapor state and getting them to deposit, so this is really where you can actually exploit the lack of gravity, so to speak, right? So these kind of materials, of course, now we're talking about engineering materials. If you look at the bio side as well, right? So bio side also, if you're going to like 3D print tissues and cells, for example, and the gravity is continuously acting on these cells because they're in a liquid state, right? So cells can collapse under influence of gravity, for instance. Again, protein crystals can form. Of course, proteins work because of the geometry, right? Now you can, the fact that you can switch off gravity means that I can make those crystals, I can make those tissues and organs and organoids in a better way, in a more, functionally they can be better. Yeah. So if you can find those materials and those, whether it's engineering or bio-related materials, and find that what kind of commercial value they have. For example, there are some materials that I can it's not possible for us to make on the Earth here, but they have a lot of value. So if you can actually make them on the, in microgravity conditions, and now if you can justify the economic value, the value add for that, then I think those will be commercially feasible. Yeah.
Is there any example you can give? For example, you can do certain electronics item like the wafer.
Yeah. Yeah. Well, I mean, one example maybe I will take is the optical fibers, right? So the internet that comes to us, our homes and offices, is typically using a silica fiber. Silica fiber is what we typically use. Okay. Now, one of the problems with silica fiber is the losses are heavy in that, so you need to have more repeaters, so to speak, in the system, and also you cannot transmit data over a wider bandwidth in silica fibers. An alternative is what is called as heavy metal fluoride glasses. Zeblan is an example. Yeah. Now, but to make the Zeblan under the Earth conditions is very difficult because it crystallizes. Yeah. Okay, for an optical fiber to work, it should be amorphous. It should not have any long-range order in the material. Otherwise, it'll get absorbed, right? So to make that material on the Earth and exploit its full potential is almost impossible to do. Yeah. But if you take that into space, and if I have to draw those fibers, glass fibers in space, because I'm going to heat the fiber to beyond its glass transition temperature, it's going to become loose. I'm going to solidify it. And the fact that gravity is absent there means I can get a fully amorphous structure without any crystallites in it, for example. Yeah. Then I can exploit that fully, and if I'm able to draw those fibers in space, bring them here and start using them for sending signals to it, then that could be a viable use of that fiber. And depending on where you find use case for it, either you can do a mass market, which is replacing silica fiber, then you have the mass production value for that. Or you can find strategic sectors where they're useful, where the value add is very high, for instance. Those are places where you could economically exploit this material, for instance. Yeah.
So let's come to the regulation. And is there, do you see any ethical or legal or regulatory hurdles to basically doing things in space in general? I think some of the material you can do it, but start doing organoid or certain things. Do you think any international regulation there? Have you thought about it? Or is?
Yeah, right now I would say the regulations are probably in early stages of development. People have not really thought through it yet. Of course, we have all this, for example, the Artemis Accord, and we are signing some accords with various countries and so forth. There's, of course, more on Moon and Mars and so forth. But the LEO orbit and how to exploit it, I think regulatory standards has to come. Yeah. And for one, as you know, manufacturing industries always pollute on the earth here, because the industry always produce some byproducts, right? And some of them we can do some filtering, and we can dilute it in the Earth's environment, so to speak, which is not possible on the LEO orbit or on the Moon or Mars, for example. So some kind of a regulation has to be required as to that you cannot actually just discard material, for example. So that is one place where I can think regulation will probably come soon. Besides the standard regulations about where you can park your platform in orbit, which is similar to any satellite-based regulation that may be required. So compared to satellite-based regulations that are already coming up, for instance, you may need additional regulations, I think, for a factory to be used in orbit, particularly from a material standpoint of view. Yeah.
Basically having a responsible.
Exactly. So, to have more sustainability. That's right. Yeah.
Like that. So from Indian perspective, so what do you think? What is the Indian scope of doing science and manufacturing and things like that? What do you see as Indian context? But I see there's a lot of companies in the US doing it, and we have in UK and Europe. I know you are also advisor to Ballon Space, who's trying to do some of the scientific experiment.
Correct.
So what do you think the Indian ecosystem lacking, and how we should be able to do it? Because we don't have any infrastructure in space. We have no access to ISS generally.
Correct. Yeah.
So what is lacking in Indian context?
Yeah. So I think from what we discussed earlier, for in-space manufacturing to work, you need to have launch capability, which I think we are very good at in India. We don't have an issue. There are many commercial startups coming now, and ISRO is spinning off as well some of the technologies. As you rightly said, we need to have a platform to be made available. So that is something India is behind on. There is some plans to build an Indian space station, is what I understand from ISRO's roadmap. But besides that, I think commercial players have to come in. So commercial space stations are already coming up in a big way in the West. So many players are there. NASA calls it CLD, Commercial LEO Destinations, is what they call it. So there will be a replacement for ISS. ISS, as you know, is going to go away in 2030, but there are 3 or 4 players that are already working with NASA to deploy this. Similarly, we have to have commercial players that come in that start deploying these stations. So besides satellites, we should also figure out how to build these microgravity platforms, which we can exploit commercially as well. So you could lease it out to ISM manufacturers who want to exploit microgravity, for instance. So that's something that has to happen in India. And of course, the third part is I need to be able to bring stuff down. So how can I dock with that station, collect the material, and bring it back down? So those are developments that are definitely required in India. But we don't have to necessarily wait for these developments to happen, because, for example, if you take, so let's say, for example, Ballon Space is building their lab, for instance, on which we're going to run an experiment, for example, for now. So there's a lot of this research organizations that are coming up. So my own center at IIT Madras is doing a lot of those activities. So we could exploit Ballon Space's platform, for instance, to do experiments. And from the experiments, we can figure out which ones are commercially viable, for example. Yeah. So there are a lot of commercial players already there. So whether it's in India base or whether it's outside India, the platforms are increasingly becoming available. Of course, they're expensive right now. But I think with more and more CLDs coming in, the cost will reduce down as well. But the retrieval systems is something we need to work on more vigorously in India. So that's what I feel. But yeah.
So I think India is planning to have their own space station is in 2035. So do you think in space manufacturing will be one of the key driver commercially justify that? Is there Indian industry are basically looking at that using Indian space station because it cannot be taxpayers' money. I think it cannot be taxpayers' money justify a space station for India itself. So do you see the commercial value?
Yeah, I think so. Just in fact, since you mentioned that we were at this conference last week, I heard directly from venture capitalists, people who are funding ISM activities, that it is economically feasible. You can justify investments in ISM. That's what I heard directly from this person here, right? Okay. So I think we should take a cue from that, and we should more and more private players from India should come in. Satellites and telecommunications, of course, is very commercially exploitation is going on right now. But these are new areas that I think private players have to step in. It is definitely if you pick the right product. So, for example, semiconductors. We talked about optical fibers. We talked about organoids, the bio side, for example. These are all products that are that can be commercially viable. Making in space, bringing it back, and make it available for the market here. So from that sense, I think commercial players have to come in and as you said, that the space stations that ISRO is building, we can do a lot of testing on that first. But then commercially, you have to have their own private space stations. India has to have her own private space stations so that we can exploit it in a better sense. So just like how US used ISS to do a lot of testing and so forth, we could use India's space station to do testing as well. But we need to have these commercial platforms available. And since we know how to launch satellites, and to me, satellite is just a mini version of a platform. We have to think beyond telecommunications, beyond collecting data and transmitting the data. The satellite can be a good platform, which I think we can launch and should be commercially feasible to launch and maintain and deploy it as well. Yeah.
So do you think general public do know the benefit of in-space manufacturing, or is it something between the people who really know, like people like your center and some of the guys like on space or some other people? But is it public aware of this in-space manufacturing, or should there be a conscious effort to educate people in public, and who should do that? In India, for example, I think
Okay.
It's,
well, I could ask the audience a question. How many of you heard of in-space manufacturing before you came here? Oh, okay. I'm glad there are at least a few hands. So that sort of tells you an idea of that public is not necessarily aware. And this is true with any new technologies that come up. Some of them could be very futuristic. You may think it's crazy that somebody's even talking about manufacturing in space. So this topic of ISM or what I call as XTEM, extraterrestrial manufacturing, I think is a fairly new topic in India, right? Public is very well aware of what ISRO can do and how commercial partners can do in terms of launching rockets. They understand what is satellites. They understand the satellite gives data back. But beyond that, I think public may not be aware of how things can be utilized in space. So from that point of view, yes, we need to have more awareness in the public. That's why I give a lot of media releases. We try to float around videos. And we have our IT Madras as an exhibitor booth here as well, so we can spread the message that India is looking at this topic as well in space manufacturing. And I think more importantly, the younger generation, the students who are there in colleges, and of course, IT Madras students now are a little bit aware of what we're doing here. And other college students have to be made aware of as well. So they understand that the space-based excitement that is there in India now can be stretched beyond what we currently exploiting in terms of satellites and telecommunications only, and it can go beyond that. So I think more awareness, more messages have to go through to the public. Yeah. Mm-hmm.
Because I think I was talking to Velong. I think a lot of scientists around Indian institutes or research institute, they don't know that certain things is possible.
Mm-hmm.
I think is there lack of education, or is just connection? What is lacking in getting more scientists and more engineers involved in this?
Yeah, so we think of space as okay, only aerospace engineers or aeronautical engineers will do, right?
Yeah.
So I think that's why it's been largely confined into launches. Now, so of course, the electronics engineers know because they are involved in satellite communication. Those are the sort of the two fields that we always connect space to, right? But now, if you, let's say if you bring in space manufacturing now, that sort of spreads the domain areas into materials and manufacturing, mechanical engineering, so forth. So I think that's sort of the way to spread the message, right? So rockets and launches and satellites is all we think of usually. Now we need to think a little bit more in this. So now we have to bring in material scientists and tell them, hey, look, this is possible to do. You can actually switch off gravity. When you switch off gravity, you have to think out of the box. What will happen? That kind of awareness has to come in, I think. Yeah, and it's coming in now, but yeah, we need to do more of that. Yeah.
So from my perspective, I think when you look at in-space manufacturing from E2MC perspective, we see the benefit directly because, for example, you have to give the example what sort of relates to human. For example, we have invested in Lambda Vision, so we can see that they can manufacture retinas, much more efficient retina, which could basically is very valuable to a person who doesn't have vision. Similarly, if we can take a drugs into trial with organoid that one of our company Prometheus is doing, so that could basically trial the drugs faster. So I think there's public benefits.
Oh, definitely.
That has to be
Yeah.
advertised.
So as you said, the health-based, there's a lot of benefit that the public can get from. Biopharma, as you already mentioned. I mentioned about this fiber optics, which brings internet to our houses and offices, for example. Or semiconductors, we will have better phones, better computers, better devices that can help deploy AI in a more energy efficient manner, for example. So those are all, I think, connected in one way or the other directly to the public, right? So definitely, I think these are technologies that we can relate to the public, and they can be made aware of these technologies. Yeah.
I think we are coming to end of the session. I think 30 minutes, right? So I think we'll let this one or two questions from the audience. I think if we have them.
Thank you for the fire chat. I have a related question. What do you think about asteroid mining to get the resources for in-space manufacturing?
Yeah, so as I said earlier on, using the resources that's already available in faraway locations, especially planetary bodies and asteroids, is something that is definitely needed. Either you're going to use it right there, or as you said, I can bring back the rare earth elements, minerals, etc., bring it back to the earth as well. Yeah. Definitely, that is something that is commercially exploitable. Yeah. As you know already, there are some countries and agencies who have done some preliminary testing. They can land on especially asteroids and drill and stuff like that. And of course, if you're going to be in the moon has certain interesting elements that can be used as well. So definitely there is a commercial exploitation. That, compared to the LEO economy that I was talking about, there's a little bit more, time is required, technologies are required to do that. But definitely that is next in line. As you pointed out, I'm glad you pointed out, the next to LEO economy commercialization potential is right there. Yeah. Okay. Yeah.
Thank you. So you talked about manufacturing. You also mentioned construction, assembly, mining just now. So I have two kind of related questions. One, when you look out 5, 10, 20 years, do you see a role for humans in these activities, or do you see it as mostly robotic? And a related question, assuming you do see a role for humans, do you think it'd be easier to train somebody who's experienced in construction and mining here on Earth and then teach them how to do it in space? Or do you think it's easier to take somebody who's experienced in space, like an astronaut, and teach them how to do construction and mining and all those activities?
Okay. So to answer your first question, I think given where we are today, right, you see, I think automation is definitely needed. We need to have a very reliable next generation of automation, I would say. Because I think NASA charges today about $130,000 per astronaut hour, for example. Right? Tomorrow, and that too given their infrastructure in place, tomorrow a commercial an agent may charge more because they have to pay for a lot more bills than NASA is paying right now, charging the public, for instance. So astronaut hour is not going to come cheap, yeah, and that is going to drive a lot of the automation. Yeah, so I would say 97% of the time you will be dependent on automation to run these factories. You will have very minimal people going there and doing stuff. Right? Now, to the second part of your question, I think that's the human presence will be more needed when you go and build habitats in the moon or the Mars, and that's where you're going to have people being there in a long term. And I think that is inevitable. You've got to have people in there. Whether you can train somebody, and I think this is a very interdisciplinary subject, I would say. So you need to have both. So somebody has to have the certain skill to, let's say I want to do construction on the surface of the moon or Mars. Of course, a little bit of different type of construction. You can't do the traditional construction. But you also need to know that, okay, I need to be on a space vehicle, I need to go there, I need to be able to figure out how to live in microgravity conditions, in the new conditions of space. So I think it's a combination of both skills would be needed so that you could do that. Yeah.
Anything else? I think that's all I think.
Thank you so much. Thank you so much, Dr. Sathyan and Mr. Raghu Das, for such an engaging and thought-provoking discussion. Now we'd like to appreciate the valuable participation and contributions of our esteemed speakers. To honor their dedication and insights, we would like to proceed with the felicitation ceremony, for which I would like to invite Mr. Rajat Ali, Senior Advisor, SIA-INDIA. I request Dr. Sathyan and Mr. Raghu Das to please come forward for the felicitation. Shivani, can you please join us? Well, thank you so much, ladies and gentlemen. We'll take a brief intermission.